So, series circuits is where we're going to start, and we're not going to talk over the top of me. So, series circuits is where we are going to start, and it's when there is only one pathway for electrons to flow. So, all the electrons that go through a series circuit have to go through the entire thing. If we think about a circuit with a branch here, for example, so if I put a branch there as well, that would no longer be a series circuit. Are we clear? That would be in series, and then it would become what we call a parallel circuit, but we'll deal with that later. So here we've got our series circuit. All of those little squiggly lines, what do we think they represent? Resistors, very good. Doesn't matter what they are, we've just got a heap of resistors on the same line. So, many resistors can be put in a series circuit together. And we're going to use that analogy we worked on yesterday with the water flowing through the pipes to think about how will that impact the following concepts. Now, we've already dealt a little bit with resistors, and intuitively you identified how to deal with that. So what do you think happens to all the resistors in this circuit? The resistance total equals R1, R2, R3, R4, R5. What do you think it equals?
Just the 1R.
Just 1R. So resistance total equals 1R?
Yeah, the one total of the resistance.
So how do you find the total? What is the total?
Add them together.
Add together. So resistance total equals R1 plus R2 plus ... I'm not going to write all those out. If you had 1,000 resistors in there, there'd be 1,000 R's. Happy with that?
Yeah.
10 amp. It wouldn't be a resistor if it was 10 amp. That'll do.
Different levels of resistors?
Yep, so if I had a 10 ohm resistor and a 3 ohm resistor, 13 ohms. So,
Are they all one in this thing? In this explanation, they all one.
yeah, I didn't give a value. So if we look here, what's my total resistance in this circuit? 6, because I've got R1 and R2. Does it matter which one I label R1 and R2?
No.
It doesn't matter, okay? It doesn't matter as far as the order. As long as I've given them a different symbol, so I know that R1, R2, R1, R2, it doesn't matter. What about the second one? What's my resistance there? 5, okay? Very good. So, let's think back to our pipes analogy, and this is where it becomes very important. Current. What do we think happens to our current in a series circuit? Okay, if I had a ammeter here, we'll call that A1, and I had an ammeter here, call that A2. Describe what will happen as far as I total, the current total.
So they stay the same.
Very good. So IT equals I1, which equals I2.
What does T stand for, sorry?
I total. Total.
Oh,
So resistance adds. Oh, let's use another word. I don't like adds together. Let's go sum. Sum of parts. How would I describe current? Yeah, what's another word for equal?
the same.
What's another word for the same? Hey, very good. Current's constant throughout the entire circuit. Will that be the same for our ones with two pathways? No. What do you think will happen there? IT equals? If I had two pathways, the total current's going to equal
Total current.
the current through one plus
Current through 2.
the current through the second one.